FA062, notification modes. The fire alarm notification system may be designed and installed to achieve specific methods of notification to facilitate the efficient evacuation of the premises. This can be accomplished by utilizing one or a combination of the following modes. And we discussed these a little bit earlier, so I want to bring these back up as these are going to become more relevant to our discussion. You have your private mode and public mode, as well as you have different sleeping areas. And keep in mind, ADA, Americans with Disabilities Act, there's different requirements that the fire alarm system is meant to be compatible with as well. Different notification modes. The requirements for these modes will pertain to audible, visual, textual, and to the equipment type. And the specific requirements are defined by the mode type and appliance type. So just kind of an overview here. The requirements for these modes are going to be audible, visual, textual, and equipment. We can't use the same signals for evacuation that we use for other types of announcements. And I'm going to review that here in the next slide. But speaking of temporal signals, temporal being that audible sound produced by a fire alarm system, if a system is making different sounds for every different event, that's a lot of different signals for occupants to remember. So it's kind of really just been narrowed down to just two different type of temporal signals. Temporal 3 is an evacuation signal. And that's typically, I want to say it's a 0.5 second beep with a 0.5 second gap, repeated 3 times, with a 1.5 second pause in between them. That is an evacuation signal, as opposed to a temporal 4 signal, which is, I think it's like 100 milliseconds. I can't remember the exact number of milliseconds, but there's 4 beeps with a longer pause between them than another 4 beeps. That's only used for carbon monoxide when it's detected. And those are the only 2 signals that are mandated by a fire alarm system to be identified. So temporal 3, evacuation. Temporal 4, carbon monoxide. All right, let's talk about private mode. Private mode uses lower output levels, and these are used by trained operators and responders, such as system operators, responders, and this is typically used in an area, remember we discussed this earlier, where if we were to have a full-scale fire alarm system just going horns and strobes everywhere, it may actually cause a panic. We talked about like a child daycare system or a hospital, where if it was in full alarm, that panic may actually cause a greater danger during the evacuation than an evacuation led by trained responders. These signals may be coded or non-coded and used to signal trained personnel only to avoid panic in specific occupancies and facilities. Facilities where commonly used, this private mode system are commonly used, would be hospitals, detention and correction areas, nursing homes and hospitals, again, guards desks, supervising stations, and the like. So again, this private mode is used to facilitate an evacuation or a partial evacuation. Again, just because there's an alarm in the west wing of the hospital, maybe it's somebody threw out a cigarette in the trash can and the trash can started to smolder, and that smoldering caused the smoke detector in the bathroom to go into alarm. There's no need at that point, unless it gets out of hand, to evacuate the entire hospital and ICU because of a smoldering trash can on the west wing of the pediatric care or something like that. So these private mode systems allow for partial evacuations as well as total evacuations. All right, we discussed private mode. Now let's discuss public mode. Public mode. Public mode design is intended to signal all occupants in the entire building or notification zone. This is done through the use of audible, visual, and voice evacuation appliances, and it's to notify occupants in all occupied public locations. These systems are typically much louder than, say, a private mode system. Remember, private mode, it was signaling just first responders or trained personnel. Public mode is signaling everybody at once. And since it's signaling everybody at once, they're going to be louder because they assume that the listeners are really not paying attention to the signal. Therefore, more signals required. I don't go to a building just to wait for the fire alarm to go off. Therefore, I'm not really paying attention for that fire alarm to go off. But when it does, I need to be able to hear it. So therefore, the system is designed to be louder, a little bit more obnoxious in a way than, say, a private mode system. Again, this is to evacuate all occupants at the same time. Typically, this is done in common areas, business areas, you name it. Now we discussed public and private mode. Now let's discuss sleeping areas. Notification appliances in these areas may also be required to be combined with a smoke detector, which is a signaling circuit as well. Keep that in mind. These sleeping areas are defined as areas or rooms of a protected premises that are occupied for the purpose of overnight sleeping. So we're talking like hotels, we're talking guest suites, you name it. Dwellings, hotels, motels, guest suites, lodging and rooming, as well as dormitories. So these are all designed to be sleeping areas. And the reason we bring this up is because there are different requirements for what the audible settings are in a sleeping area and the visual settings are in a sleeping area than, say, maybe a corridor. And most of that is measured at the pillow level. Meaning, is it visible from the pillow level? Is it audible or hearable at the pillow level? For example, an independent living facility uses a type of system consisting of smoke detectors in each unit's bedroom. This alarms the individual unit and also sends a signal to the occupied location annunciator. The trained personnel may then investigate the alarm to operate the building fire alarm system to notify the occupants of the building, and notification to evacuate the building is accomplished by the use of a horn strobe installed in all building areas, including each bedroom unit. Household standalone equipment in sleeping areas may consist of a multiple station smoke alarm that are located throughout the dwelling and interconnected to each other. When any one smoke alarm detects a fire, all interconnected smoke alarms sound the alarm. Meaning, let's say downstairs in the living area, smoke from the kitchen because somebody burnt something makes its way into the living room. That smoke is picked up by the smoke alarm, and that smoke alarm decides it's going to wake everybody up that isn't already awake, and it starts to alarm like it should. Well, that's on the first floor. Well, let's say that there are bedrooms on the second floor, and those smoke alarms are interconnected to the living area smoke alarm. So the smoke alarm in the living area begins to alarm. That means that all the bedrooms are going to alarm as well. So if there's an alarm in any area, it alerts all areas. And ADA. Passed by Congress in 1992, the Americans with Disabilities Act, or ADA, is to provide equal access to all building features. For fire alarm systems, this generally includes the manual fire alarm boxes and signals. So that means that our pull stations and our alarm system notification appliances have to be visible and accessible according to ADA standards. Signals must be provided for blind and persons with profound hearing loss. Compliance with NFPA 72 will exceed these ADA requirements. So keep that in mind. NFPA 72 is designed to go above and beyond the ADA requirements.